Morning, everyone. Good morning. Good morning, everyone.
Good morning.
All right. So please just give me like 20 seconds. I'll get back now. 20 seconds. All right. I'm back. So good morning, everyone. Hello. Good morning.
Good morning,
Good
sir.
morning.
Yeah. So how is the weekend going? How is the weekend going?
We thank God.
Weekend is fine.
Okay. I'm coming. All right, so we'll be rounding off today. I'm sure you know that. I'm just trying to take time so that we can have lump sum of people join the class. All right, so I'm sure you've gone through the recordings and the slide presentation of the ones that we've done, and I'm sure you don't have any question, because I presume that if you have any question, you would have asked through the platforms, that is the WhatsApp platform, or you chat me privately. But since I didn't get any, so I can assume that everybody is in sync with what we are doing. All right, so I'm not expecting you to get everything at a spot. All right, remember, like I mentioned to you when we started, I said this is a marathon, not a sprint. All right, so that's the reason why I took my time to prepare a timetable for this year. All right, and the one we are doing is the one we are doing now is free. It's just like an eye opener to bring us into the realm of CNI, so that we'll be able to understand how CNI is and how to differentiate between CNI and other systems. All right. Like I keep mentioning to you that I don't do residential. All right. But when it comes to CNI, utility scale, that is the ones that I do. All right. And forget about the definition you see about CNI regarding capacity. Some will tell you any capacity that is below 500 is CNI. Don't mind that textbook definition. All right. CNI simply is where you are selling power and the person is paying you. For a business owner, as far as the facility is making money, all right, and you decide, okay, I want to reduce the cost of my production, I want to reduce the cost of electricity, I want to go green, then you decide, okay, we'll come and put solar on my facility, all right, and you are selling solar to the person, and the person is paying you regardless of the capacity. That is strictly what C and I. So forget what textbook is saying, just focus on the basic, what you understand by it. Now, my strength when it comes to CNI is design, because when the design is bad, then forget about making profit from it, and forget about operations. There are countless of projects in Nigeria here that has failed as a result of poor design. So, and when I mean has failed, is that it's not like it's not producing, but the money is not coming forth. And what is the essence of having a project that you've invested hundreds of millions, all right, and the profit is not coming? So it's as good as failed business. All right, so now I'm going to share my screen now so that I can show you again, because I've shown you before. I want to show you the plan that we have for this year's training, so that you see where you can fall into, and you plan accordingly as well. All right, so just give me a second while I launch my screen to show you. I'm coming. Few seconds, please. Coming. All right, so now let me share my screen so that you can see. If you can see my screen, kindly signify, please. What we are going to do today, like I mentioned to you, is we are going to go more of practical, like like a case study, not really practical per se. So can you see now? Can you see my screen? Hello, can you see my screen? All right, so this is the training for this year. Can you see training for 2025? Can you see it? Can you just unmute yourself and say yes? You understand?
Yes.
All right. So is it so? The first one that we are doing is the introduction to CNI solar PV design. Now, once we are done with this today, all right, then by May we are going to start up with the with the softwares. We are going to start with SketchUp, Homer, Helioscope, and AutoCAD. All right. The reason why I'm taking the AutoCAD is because if you want to move to PVKs, you must know what AutoCAD is. In fact, AutoCAD is the main tools. All right. Now let me show you a design that I did for a client. Let me just show you so that you see how design usually is, so that you feel, no, I know design. You know, fine, I know that you know design, I know that you know how to use AutoCAD, but there are stages in which you can use AutoCAD. All right, so can you see my screen now? What can you see? A proposed 180 kilowatt solar hybrid solution. This is for a mini grid. Can you see? So this is the title page. Can you see it? Can you see my screen, please?
Yes, I can see it.
Yes.
Right. So can you see this? Right. This is the schematic. All right. So can you see where the solar panel is? This is the generator. These are the inverters, the BS, the controller. This is the feeder. You can see. So this is a full, how many pages? 19 pages. So this is the earthing part. Can you see green cable? This is earthing. All right. So this is the cable size. Remember, I mentioned to you that your design is not complete if you don't have a proper cable schedule. So this is the electrical cable schedule. The size, this is the PV cable, that's the DC cable. So this is the layout. Can you see it? So this is strictly the layout. It's a ground mount. So this is the layout. All right. There's a way PVCs will give you layout. I mean PVKs, right? This is actually how to get layout using AutoCAD. All right. But if you want to go further to be more professional, then you'll be talking about PVKs. All right, so can you see what I'm able to use AutoCAD to achieve? So this is the AC conduit. Can you see? Now let me show you PVKs. Let me show you what PVKs can do. Let me show you the layout of PVKs. Let me show you the layout of PVKs so that you see what you are going to learn. All right, so let me just show it to you. Okay. Let me show it to you. I'm coming. Okay, so let's start with this. Can you see my screen? Can you see my screen?
Yes, we can see it.
All right, good. So now, when you look at this now, this is actually PVKs. Now, when you look at this is actually the facility that we want to power. All right. This is the facility that we want to power. Now, this is the area that the client specified that we should use. So now, with this area, we are able to superimpose the solar. This is exactly how it's going to be at the plant. All right. Now, this one is already running. This is phase one. Phase one is already running. Where you have this green line like this, this is phase one. It's already running currently now. And this is how it is exactly at the site. All right. Now, this is the phase two that is going to come up. So by the time the installation is going to commence and we are done, when you have a panoramic view of it, this is exactly what you're going to see. All right, because PVKs will help you to get the coordinates, the latitude and the longitude of each piece. All right. So what you need to do is just to print out all the coordinates of all the pies, give it to civil engineer, then they will just ram it. There's what we call ram. They will just bury the pies like that. Once they identify the coordinate, they will bury it. Identify the coordinate, they will bury it. So once you do like that, everything will align. All right. So this is what PV case. So you're able to achieve the PV case is actually a plugin in PV's AutoCAD. So for you to be able to do PV case, you need to know AutoCAD. Now, once we are done with PV case, we can now export it to PV6 for proper simulation to know what the annual generation will be. PV case can also do shading analysis. All right. By the time you are doing the layout, you can verify if there is going to be a shading in the winter, in the summer, in the equinox. You'll be able to confirm that. All right. SketchUp can also do layouts. When you talk of layout tools, SketchUp and PVKs are systems that can do layouts. Homer, Heloscope, PVCs are simulation tools. All right. AutoCAD is a design tools. You know, you can use it to do CMS schematic diagram, SLD as well. Now, once we are done identifying this, then we now go to the monetary part. All right, because you need to know if the project is going to be financially viable or not. Once you know that, then you'll be able to do your design. So once you know what the financial is, it will be able to judge your design principle. You'll be able to know that, no, let me not use this system because according to the financial modeling, it is not feasible. You understand? So now, after we've done all this for 2025, then you should be able to count yourself as a CNI expert. All right. So that is it. So now for you to, we are starting this May, but this is actually going to be a paid training. All right. But for those of you that have the certificate, you are going to enjoy an extremely discount. You understand? Because I wouldn't want to charge you much. You pay extremely a discount amount of this. Now, if you go out there and check the cost of all this training, I'm sure you know you pay a fortune for it. Or I'm currently doing a training now and I know how much I paid for it. So that is not to discuss it. All right. So that is just to bring you up to speed regarding what we have ahead. All right. So now let's now move on to what we have today. Are you still with me? Can you still hear me? Can you still hear me?
Yes.
All right. So
yes, we can.
Yes, let's move to what we have today. All right, good. So let's move to what we have today. Today, we are going to be looking at solar PV design. Solar PV design. I guess you can see my screen, right? Can you see my screen?
Yes, we can.
All right.
Yes.
All right, good. So this is it. Solar PV design. Now, this is what we're going to be doing today. We're going to be seeing the solar project life cycle. All right. For every project, there is a life cycle. I'm sure you know that. So we're going to look at the solar aspects on. All right. We're going to see the aspect. The solar project life cycle is very simple. You understand? Before, what you need to do first is to do as the business owner. All right. Please mute your mic. If your mic is on, please mute your mic, please, so that there won't be distraction. All right, thank you. All right, so the project life cycle is simple. From the beginning, the business owner that feels I'm on band A or that feels I'm consuming much energy needs to save costs. All right, so once he realizes that, then he will reach out to a solar company. All right, that this is what I'm experiencing and I need to reduce my cost. So what can you do? So that first process is lead generation. All right, so if we don't have it like that, it can be the business development guys from a particular solar company that is going up and down looking for a prospect. All right, and once he cites a prospect that, oh, this customer is, or this business owner is consuming much energy, then it needs to solarize its facility. All right, so that is basically the first step, which is lead generation. All right, so once that is identified, then you proceed to the sites to do your assessment. All right, with your assessment, you do a lot of things. All right, you'll be able to do your energy load. That's the main thing, because what you want to power is the load. It is the load that is actually leading to high costs. So that is the first thing that you need to do. You need to do your logging. All right, that's the energy audit, to know what the customer load profile is, to know, because what you want to bring in is solar, and you know that solar only operates during the day. So once you are able to log, you'll be able to identify the load pattern that, oh, these clients consume much load in the evening. Therefore, there is no how we can do this system. All right. So what you need to do, once you do your load project, you can advise the client to move his operation to the day. All right. Whichever way, by the time you are able to finish your logging and you are able to analyze the data, you'll be able to identify the trends, all right? You'll be able to know what is going on with the load profile of the client. Then the next thing is to identify the space, if it is ground mount or if it is, roof mount, all right? If it is ground mount, what you need to do is just to identify the area that you want to put the roof, the panel rather. You need to tell the client that which area is he allocating, all right, for the installation. Remember the PV case one that I just showed to you now is actually a C&I, all right, because that is a factory that we want to power, all right. So you can see the area that the client allocate for us, that, okay, don't go beyond this. This is the area that you can do your solar plants, all right. So if it is the roof mount, once you identify the roof, you still need to carry out structural analysis on the roof to know if it can accommodate all your panel, all right? And that can be done with the help of a structural engineer, all right? So once you've done that, you factor in a lot of things, check if there is going to be shading where you're going to put your panel, if it is roof mount or ground mount, all right? Identify the orientation, identify how you are going to move in your equipment, all right? Because during installation, you need to factor in if there is going to be a space for trucks to pass through, all right? If there is not going to be a space, you need to, see how you can make a way. You understand? So those are the factors that you're going to see during assessment. So once you've done all that, you do a preliminary design. Once you do a preliminary design, you send it to the client. The preliminary design will have the costs, all right? Now, once it have the cost, then that takes a lot of process. Because the client can tell you adjust this, you guys will be going back and forth, trying to see how much the client is going to be paying. So that can take a lot. In fact, it can take years, all right? Because anything that involves money involves a lot of dialogue. So it can take years, all right? Then after everything, the order will be confirmed. Order will be confirmed simply means that an agreement has been signed, all right? The business owner, everybody, all the stakeholders have agreed, okay, we cannot go ahead. Then the next thing is execution, all right? Now, during the execution, you now start with a detailed design. Remember, the one you've done initially is preliminary. You now start with a detailed design, all right? Detailed design means what you are going to implement at the site, all right? So the one that the SLD, the AutoCAD design I showed you is detailed design. That is how detailed design is, all right? You have to factor in how you are going to bring in your equipment, how it's going to be in real life. All right, so there are a lot of things involved in detailed design. Then once you are done with detailed design, then you begin your project execution. That's the project aspects. Execution, you move to the site with the project technician, you start laying your panels, stringing, doing commissioning, and the rest. So once you are done with that, then you hand over to the operations and maintenance. Then that is the operation and maintenance will now continue the project until the life cycle of the system. All right. So that is basically what projects solar project life cycle is. But don't worry, you'll see it. I just want to take you through this so that you understand better. Then after we see DC and AC couple system, I think you must be hearing me mentioning DC and AC couple system, DC AC couple system. We are going to see that. Then we have sorry?
I was telling someone to mute the video.
All right. Sorry, please. I don't want to see your face. Just mute your mic, please. Now we are going to see factor 1.0 rule of AC coupled system. All right. This is very, very key. For those of you that are service guys, if you don't obey this rule, even those that are designed, you must know this rule for you to be able to design an AC coupled system. Then we'll see a case study for an AC and DC coupled system. Then we'll see steps in designing on-grid system. We'll see case study of an on-grid system, calculation of energy yield, monthly energy yield, then performance ratio, specific yield, and capacity factor. So these are the parameters that determine if your system is profitable or not. These are the metrics. All right, so now at the end of this section, you should be able to know the step-by-step approach in designing DC. Do electricity, you take the electricity bills or you log, all right? You do roof drawings, there's a way you can even know the area of a roof, all right, without even visiting the site. Then you analyze the load details. So it is the load details that will help you to be able to do the preliminary design. So during the preliminary design, you do your simulation, you do your CAD drawing, then you prepare bill of materials just to know what the capex is going to be. When I mention capex, I mean capital expenditure, all right? Don't worry, when we get to financial modeling, you'll be able to hear all those terms. Now, the proposal, if you are sending a proposal, you send the cash flow, financial analysis. The proposal takes a lot of time because it involves money, all right? So it can take years. Then after every back and forth, once the order is confirmed, both agreement has been signed, then you come up with the detailed design. You can see module layout, singular diagram, structural design. Detailed simulation is more than this because there's going to be a risk assessment as well. Then after the execution, project execution come in place. All right, so now what is involved in the preliminary design? Electricity bill or usage or logger reports, estimation of solar capacity needed, all right, analysis of local utility codes and requirements, analysis of roof space, analysis of roof strength. Now, utility bill usage. Whenever you have the client utility bill, all right, what you need to check for is two things. You don't need, if you are doing design, if you are doing preliminary design, you don't need the costs, all right? You don't need the bill. What you need is the energy in kilowatt hour, and you need the duration, all right? Because you might be given the energy bill quarterly. All right, you might be given monthly, but if it is monthly, you don't need to check for that duration. All right, so once you have that, then you can proceed with you can now get your solar capacity. All right, so now let's move on. Now, in analyzing electricity bills or log data or data from the client, the most important parameter you need is the energy in kilowatt hour. Can you see it? In kilowatt hour, not the money. The important parameter that you need is kilowatt. Now, for electricity bill, you can see, check the number of days. That's the duration that I'm talking about. The bill, check the duration of days the bill was issued. If it is month, use 30 days. If it is quarter, use 90 days. It is also very important. Now, from the electricity bill, to calculate the daily consumption, remember if it is monthly or quarterly, you need to bring it down to daily because your energy from the sun is daily, all right? Not monthly, not quarterly. So you need to break it down. All right, so from the electricity bill to calculate the daily consumption, simply divide the energy in kilowatt hour in the bill by the number of days it was issued. If it is 30 days, you divide it by 30. If it is 90 days, you divide it by 90. All right, so that is for electricity bill. Now, for the log data or data from the client, it is important to narrow the energy to daily consumption, all right? Now, based on the daily consumption obtained in units, we can estimate the solar capacity using the solar irradiance and obtain the PV. We are going to see that. Now, using Global Solar Class website, I'm sure you know that we've done this. I've shown you this website. The solar capacity is estimated by dividing the obtained daily consumption by the PV potential. We are going to see that. Now let's just look at that. Now let's assume. Are you with me, please? Are you with me?
Yes, sir. Yes, we are with you.
Good. So now let's assume. Let's start with the electricity bill. If you maybe after this call, you can start searching for any electricity bill that you might lay your hands on. All right. So now let's start with the electricity bill. Now let's assume that I have an electricity bill and it's issued to me monthly. All right, it's issued to meet monthly, and what I can see there is every month the energy that is being consumed by this business owner is 150,000 kilowatt hour. All right, 150,000 kilowatt hour. Now, what will be the daily consumption? I need you to tell me what will be the daily consumption. Let me repeat it. A business owner wants to go solar, right? And is requesting company A to come and do the installation. So the company A is requesting for the client utility bill. All right, let's start with just 1 month. All right, it's requesting for just 1 month, that's January. All right, and on checking it, the solar company on checking it, you realize that the energy for the month of January is 1,000. That's 150,000 kilowatt hour. All right. So now I'm asking a question. Now, what would be the daily consumption?
5,000 kilowatts.
1,000 kilowatt. How did you do it?
5,000
kilowatt. How did you do it?
5,000 divided by 30.
Divided by 30. Good. You divide it by 30. All right. So that is the daily consumption from the facility. Now, since I have the daily consumption and I want to size my PV capacity, so what will I do? I just need to divide that daily consumption by the solar insulation. That means the duration in which I can have my solar within that region. All right, that's the PV potential. So if you want to do that, let's just go to solar. Let's go to Global Solar Atlas. You can still see my screen, right? Global,
Yes, sir.
All right, let's go to Global Solar Atlas so that I can show you. So this is good. So this is the side. Now, depending on the location that you are doing your installation, let me assume that the installation is in Abuja. Let's just do it this way. Let's do it like this. Now, remember, when you are going to do during your site visit, part of what you are going to get is the coordinate of that location. All right, coordinate of that location. So when you come to this Global Solar Atlas, just type in the coordinates. No need of you putting Lagos. When you put Lagos, it can take you to, Lagos is very broad. So streamline it to that location by getting the coordinate of that location, right? So just type it here, then hit enter. Once you hit enter, then you can come here. Can you see? So when you come here, this is you can see this is per year. That means that the duration of energy that I can get from this capacity. Sorry, can you give me like 10 seconds? Let me attend to someone. I'm coming.
We are not seeing what you are doing.
Not seeing the solar atlas.
Hello, guys.
Je ne comprends pas.
Bonjour.
So you can see my screen?
I can't see anything though. Yeah, I think it's static or something. Because you're explaining, we are not seeing the screen.
Yeah.
All right. So what can you see on the screen?
It's not the right one because you were explaining the
design.
All right. So now let me reshare again.